Inverse functions are denoted with a -1 looking exponent, but that exponent does not mean that it is a negative exponent. It's just telling us that you're looking at a inverse function. So sometimes they'll show it as y to the power of -1. I know we've seen that in the exponentials unit, but now when they want to show that a function is inversed, usually they will show like this, f of -1 of x. This is just telling you that we need to invert the function. Okay, so inverse, we know what inverse operations are, right? Positive, negative, multiplication, division. You have exponents with roots. Inverse functions means that what you start with, you're going to have like a y equals some x stuff. You need to take all your y's and replace those with x, and you need to take all your x's and replace those with y's, and then solve for y. And it's going to be so much fun. So that's what a inverse function is. That's what it's saying right here, exchanging all your x's with y's, then manipulating to solve the equation. That's like a literal equation. So again, just keep in mind when you see this, because we get so trained with the exponent stuff that we're like, hey, this is to the power of -1, so you just flip it as a fraction. No, you're not flipping it as a fraction. You're flipping essentially the variables in that. Algebra to find the inverse function. No problem, I got it. So on this one, I would rather look at this as y equals, just because I don't want to be replacing f of x stuff in there. Okay, so this is the same function that I just wrote, not the inverse function. If I want the inverse function, then wherever I have a y, I'm going to replace it with an x. And wherever I have an x, I'm going to replace it with a y. So this then becomes x equals 9y plus 6. And then we, just like we saw on that last slide, then solve for y. Okay, so if I was to solve for y, and you may do it differently, I suppose, but I would use some principles of equality. Some students would even want to switch the sides on this so it's y equals. Doesn't matter. So I'm going to subtract 6 from both sides. I'm keeping this -6 separated from the x because they're not like terms that I can combine. So then I've got -6 and a positive x, and then this would equal 9y because we've zeroed out the 6 as planned. The last thing we want is for the 9 to not be a 9. We'd like it to be a 1. So I'm going to have to use another principle of equality here to divide both sides. Well, all the terms, I suppose, by 9. You could just divide both sides by 9. So the -6 over 9, that's going to simplify to -2/3. Then I'm going to show this as a positive 1/9 x. You could show it as x over 9 if you wanted, but then we get this equals y. Now this is my inverse function, so I need to indicate that it is an inverse function here at least. Some students would say, well, you should have shown that throughout. That's fine. Once we switched the x's and y's, then then you can show that inverse function. You know, I was skipping that just so it doesn't not get confused as an exponent. But in the end, we definitely need to see that. And if you wanted to see it in function notation, you could, as f inverse of x equals, we have -2/3 plus 1/9 x. Same exact thing.